Episode 11, Chemical Exposure Limits. My name is Dr. David Ayers. This is the Occupational Safety Leadership Podcast. Let's get started. So as we look at chemical exposure limits, there's a lot of different ones for the U.S. The one that's legally enforceable is going to be the OSHA PEL, the Permissible Exposure Limit, and along with the PEL, you'll also find other ones like a ceiling, which means you cannot go over that exposure. Certain chemicals are going to have a OSHA action limit. We'll talk a little bit about that as we get going, but you will also find exposure limits published by people like NIOSH. They have a recommended exposure limit, a REL. The TLV, or threshold limit value, is from the American Conference of Governmental Industrial Hygienists, and I've also found quite a few company-specific ones where there was legally no published data out there, but what they had is a occupational exposure limit for the company. So they said, as a company, that we will not exceed this limit. Let's go on here. Let's talk about the first one here. So the PEL, Permissible Exposure Limit. So most of the PELs, I'm not going to sit here and bore everybody by doing a word by word here, but most of the PELs were adopted back in the 1970s when OSHA had first started. So as time goes on, they are trying to go back and update these as we gather more data. But like all things, you have to go through the whole legalese. As you promulgate a rule, you change things, you have to give people adequate time for comment notice. Also, in a perfect world, of course, you want to make sure that people are ready for this change, because you could take a person who's operating in legally right now just fine, and if you spring a change on them overnight, they are now operating in an illegal fashion, of course. So it's actually reasonably hard to go back and change these. Let's go to the next slide here. A little bit more on the PELs. So the PELs are going to be weighted on an 8-hour exposure limit then. So back in the old days, I'll say, because I'm a little bit older, which person worked at a chemical plant or manufacturing place or something. They literally were in the workplace for 8 hours a day. That doesn't always happen now. It still does, of course, but there are with the advent of the computer, there's a lot of times where data has to be entered into a computer. A system is being monitored, and so that is obviously a opportunity to get less exposure. In the ideal world, you get zero exposure out there. So, but let's look at a couple of examples out there. So when we think about acetone, it's 1,000 ppms, ammonia 50 ppms, and hydrochloric acid at 5 ppms. The ppm is parts per million. Also with the OSHA, we have the ceiling, of course, and that is going to be that limit that can never be exceeded. Action level there is going to be is that level of harmful or toxic substance, like ... and then from that point on, you have to look at monitoring for this specific chemical that's out there. And when I think of a few, you have a lot of the ones like lead and beryllium, formaldehyde, and there's going to be some other ones out there. So these are very specific. So just a couple of examples here of a ceiling. With hydrochloric acid, we have 5 ppms, boron trifluoride 1. A STEL is a short-term exposure limit. So we have here benzene at 5 ppms, and an action level. We talked about a couple of these already. So at the formaldehyde, the 0.5 ppm. So now we're starting to get a little bit lower. Lead, 0.3 ppms. beryllium 0.0001 ppms. So these are very chemical specific things that have to happen when this threshold is exceeded. That also means that we have to have that good sampling data out there so that we know when that exposure is exceeded, so that we also know how to go back and engineer out these solutions. NIOSH has their REL, which is based on a 10-hour work shift for a 40-hour work week then. So for them, they have ammonia at 25 ppms as opposed to OSHA, which has 50 ppms. Benzene is 0.1 under the REL. OSHA has it at 1 ppm. So also considered a carcinogen. And boron trifluoride, they have exactly the same one, and it's also the ceiling. So they're so the REL, the PEL, and the ceiling all have the same exact exposure. The next one here, we have the ACGIH, American Conference of Governmental Industrial Hygienists. They have a 8-hour time weighted average, and so theirs is called the threshold limit value. So let's do a couple of comparisons here. So ammonia at 25 ppms, 35 is what they have for their stale short-term exposure. HCl is at 2 ppms. They also call that the ceiling, where OSHA is 5. Acetone is 250 ppms, whereas they have 500 for the ceiling. And nitric acid, 2 ppms with a 4 ppm stale short-term exposure limit. So all of these have just a little bit different. Some are exactly the same too, of course. The key is that you go back, is that you know what that limit is out there so that you can go back and engineer out the hazards. A couple of other ways that we look at exposure. We can do it by atmospheric sampling. So we're going to wear a sampling pump, and we're going to take a sample of air from the operator's breathing zone, which is typically defined as a foot around their mouth, and kind of like that omnipresent circle there. So we're just kind of seeing what the atmosphere is. You can also do a wipe sample. Typically, these are things for like lead and other things, and you're just kind of seeing what's around then. You can do a biological one, which is a draw of urine or blood. These are not used too often, but they are used for things like lead, because you can see how much is coming out of the human body. And let's go on to the next one here. There's other ways that we can do this, of course. So when we look at how that we're going to gather this data, we really have to look at a OSHA or a NIOSH method out there, which is going to be a prescribed way to take your sample, so that you're going to take it exactly the way that you have to take it for the standard. You're also going to send it out to a lab then that can go back and analyze it. So I'm not going to take a sample for hydrochloric acid and send it to just any old lab, anywhere. I have to make sure that if I'm going to take it per OSHA standard, that the lab can also analyze it per OSHA standard, You can also call up the lab, because there's a lot of different, if you're going to, let's go back to things like hydrochloric acid then. So there's going to actually be several different methods out there, and it really depends on what what is present over in the workplace. So lab can really help you to define that then too. You got to follow the exact method, or else you could have some invalid results, of course, which is almost worse than having a overexposure, because if you don't have a good sense of trust in the workplace, a lot of times the workers think, well, if it came back and it wasn't somehow right, that means that it must have been high, and the company is just not going to communicate that to us. So we have to sit down and do it again, take another sample until it's actually low enough for them to go back and communicate that to us. And while we're talking about communication, you have to communicate the results to employees within 14 days also. 14 days is plenty of time to go back and find these folks. And I understand vacations happen. There's people who work, nights and weekends and things. So sometimes it can feel like it really like people need all 14 days to go back and really make sure. And thank you for joining me today, episode 11, Chemical Exposure Limits. I'd like to thank the Occupational Safety Leadership Podcast for helping to sponsor this. Please subscribe. My name is Dr. David Ayers, and have a safe day.